Hello everyone, welcome to GeoNodes challenge series where I explore the potential of geometry nodes to show you what amazing things you can achieve with this procedural modeling and animation tool that Blender has. This very cool project, hologram map of a planet, allowed us to learn a lot of stuff like you saw at the beginning. And today we will continue by looking at how you can create a particle effect, the one that motivates this hologram. In the previous video, I showed you one method. Now I'm going to show you another one. If you are curious about all the other stuff that we did, you can find it all here. Check the link in the description to start from part 1 or watch any of the parts that you find interesting. We created the flight paths, we added the tracer and the animation, and we exposed some values for the shader. We also created the inner particles, the one that you see here. And of course, we have this mesh that comes on the outside, like this. So today we will be creating another particle system, the one that will follow the shape that we provide. I'm going to use a cone, but you can use anything you want and it will work just fine. Before we start, as usual, I want to give a big thank you to all of you that are supporting this channel by subscribing, commenting on the videos. That's very important. It gives me a feedback and it helps me improve the videos. Also, big thank you for the people that are placing a like on the videos. This channel needs your support. So thank you for all of you that are also deciding to support me by purchasing the project files on Gumroad, while also getting a very cool project that they can tweak and use to do whatever they want. So thank you all of you. Now let's get started with the video and let's see how we can use a shape to sculpt a particle cloud. Okay, so I'm gonna start by taking this frame from here, and we will be adding our cone shape, and I'm gonna plug it here into our setup like this. Okay, this will be hologram motivator. Excellent. First thing that I want to do is to flip this shape, because now it's just the opposite of what I want. And we can do this by rotating it around the x-axis by 180 degrees. So now we get this. And because I want to build a procedural setup, I want the shape of the particle to take into account the shape of our object. So if we make it bigger, it will know that this is happening. For that, we will be using this exposed parameter, hologram radius, that is basically this value for the base icosphere. We have this hologram radius. So let's just do Control C, Control V. Come on. Okay, Shift D if you don't want to do it like this. So I'm using this node and I'm gonna port it here into our setup. Okay, so now we are here. Excellent. So let's start to build our cone in a way that will take into account the size of our mesh. So we can do it to change things procedurally. We want to control, let me put it like this. We want to control this height. We want to control these sides, the circumference, and the bottom one, and make it procedural. Then we will use this shape to distribute points on the surface. We will make then points to go towards inside to fill the volume, and then we will do the other stuff that I showed you in this. I'm going to show you here. This is what exactly we will be covering today. So let's start by doing this part, and then we will do the distribution. So how can we control the height? We can use this depth control from here, and in order to make it procedural, we can use this radius, and we can plug it here, and we can make it go down by adding a math node, and that's going to control this value. So let's do something like this, and I want to make this an input, so I know it's an input. Now let's control the radius of the top, so let's do this one and plug it here, and that's gonna be, in our case, the bottom. So we can choose just how big or how small we want it to be. But let's do first the bottom, that is our actual top right now. So let's add something, make it go outside just a little bit. And for the former top, that is now the bottom, we can do something else. Let's do a percentage of this radius. So let's duplicate this node and switch it to divide. Take this value and divide it by something, let's say 3, and now plug it into the top, and that's going to give us a percentage of the radius as our bottom. Let's leave it at 3 for now. Awesome. I'm going to switch now to actual geometry, and now that we have this procedural setup, let's turn this into a cloud of particles. We can do this by using an distribute points on faces, and immediately we see we have points instead of that geometry, and we can increase this value to get more points. At the end, I'm going to show you in the finished project how I turn this into a parameter and expose it outside. For now, let's just leave it at a round number like 200. That's going to give us some points here, and now we can play with that. We want to make those points go inside, and for the moment I'm going to hide this mesh here and also all the other stuff, so we can focus on this particle system here. And because this visualization, it's actually not looking very nice, it's difficult to see what's going on. Let's do now this part. About not the animation, we will wait for the animation. Let's just do now the turn to points. Okay, this is what I was looking for. How can we do that? Well, let's do instance on points. We have these points here, and we can add now a mesh for those points. We can use a cube, and let's give it a value. Now we can see better what's going on, so we can go back to doing our random distribution of particles, because we want to push things inside in a random fashion. And in order to do that, let's use a geometry set position node, because we want to move points. At this point we have points. And how can we move those? Let's take the position that they already have and we can plug it here. Nothing is going to happen, but if we use a vector operation on this, and that operation will be scale, we can control now this. We can make the points go, if we put it 0, all the way to 0, and 1 is their original position. So if we use now a random value with a 0 to 1 range, we can plug it here, and that's going to give us a random distribution of the points, because some of them will be pushed towards the center here and some of them will be left on the outside, and that's going to be something we might want to change. So let's turn it green. Okay, so now we have a random distribution of the points. I want to move to the next thing, and I want to build a mask to make these points appear from bottom to top, like we saw in the demo, to make them appear together. So in order to do this, I'm gonna build a mask, and that mask is gonna be based on the Z height of this entire setup. So the entire setup that we have here, let's just push it a little bit like this. We care about this part that we created here. We want to find the Z height, and we can do this by using a bounding box. Plug it here, and now that we have this bounding box, we can find out the minimum position here and the maximum position here, the real position. And for that, we can do like vector separate XYZ and take the minimum of this. And we will be using this value. Okay, I just connected temporarily to be able to hide the other inputs. Let's duplicate this node and put the maximum here. And now we have a range that we can play with. So if we push these nodes a little bit more like this, we can do a bunch of stuff now here. After we did this setup that redistributed the points, because now we have this mask here that is giving us the minimum and maximum range for the Z height. We can use that one to build a mask. How? We can take the position and let's put it in context. I'm gonna do a delete geometry here on points. So we will build a mask, we will be plugging it here, and that mask is gonna take the position of the points and compare it to these values, and that's gonna give us our mask. I'm gonna show you what I mean. So now we have the Z position of all the points, and we can do a compare operation and say delete all the points that are not equal on the Z position with the maximum height. And now we can plug this one here and nothing changes. But as soon as we start to play with this parameter, we can reveal the points, as you can see here. Let me just put it like this. So when we get at 1 and build above 1, we can just play with this value. So this is why we did the bounding box, because we don't know exactly the maximum value here. That depends on how high the mesh goes. So we also don't know the minimum value, because it might not be 0. So that's why we have this thing exposed here. So right now, if we do a map range and we take this as a minimum and the maximum as a maximum, and we plug this one here into the epsilon, if we keep this to 0 to 1, we will get a factor that will be revealing the entire mesh at 1 and hiding it entirely at 0. So this will be our animation factor. Something that we can actually expose. Let me duplicate this node, and I'm going to expose this value here. And let's look at here. I'm going to go to the group. This is the end panel, by the way. This will be reveal effects. I want this to be clamped between 0 and 1. And now I have this output here that's going to control our effect. Excellent. So now we finished with this reveal effect in part, because there are two things that I want to do. Number one, I want to create that animation for this particle. And number two, I want to sync this with our planet hologram to make them work together like you saw in the demo. So let's do the animation part first. And that's going to be this part. Let's see. We created this instance on points. So let's move those a little bit here. And after that, I want to do an instance, translate instances, and start to play with these instances here. So let's do this. What I want the particles to go up and down. So I want to affect their Z position. So let's start by taking the position. We can use this node from here, plug it here. So now we have access to the Z position. We will, of course, add the scene time. And if we want to make something look nice and organic, we can use sine and cosine. So let's take this frame from here, plug it here. And once we did that, we can take the position of the points and let's just multiply it by this value from here. And now that we have this thing going on here, let's combine a vector, plug this one into the Z. We will leave this at 0 and put this into the translation. And as soon as we do this, we get this effect here. So let's now add a speed control. I'm gonna make this one green and do like 0.2. Yeah, I think this is too slow. 0.5 maybe. Something like this. Excellent. If we play with this value, it's not gonna give us any different results, but there are other things that we want to play with. So let's see. This sign is giving us values between -1 and 1. And if we mute this node, we can see that it's basically pushing things up and down while keeping the top constant, and that's good. So we basically don't need to do anything else. Unless you want to restrict the values, then you can remap the 0 to 1 value to something else to get a different effect. But I'm gonna leave it like this. The only thing that I want to do to this animation is to stop making it like this, like an accordion. I want to add variation. And for that, we can simply use a random value node. I'm gonna give it a color. And this random value, let's make it like from 0.1 to 0.8 in this case, maybe, or even 1. And plug it here as a multiplying factor. And as soon as we do this, we get this kind of animation that is looking like something it's basically flowing and dripping. And that's kind of what I wanted to do for this animation. Let me quickly just frame this, plug it into this frame and give it a purple color. By the way, you can change the color here and then save it as a preset here by pressing plus and give it a name. So now that we did this animation, I want to make it take into account the planet. Because right now, when we play with this reveal effect, the particles disappear, but the planet doesn't care about it. So we want to modify this planet thingy here. And the way to do it is by adding a transform node. So let's get a geometry, transform, plug it here. I'm gonna make a frame for it, and we will play with the scale. So let's take this node from here, Shift D, Alt P to remove it from the frame and plug it into this frame. And now we can use this reveal effect to affect the scale. We can plug this float value directly here because we want to affect things uniformly. So now when we do the reveal effects, at 0 we have nothing, and then the planet starts to grow. How can you make like a bouncing animation to this? Well, you can do utilities, float curve, plug this float curve here, extend it so you can play with it. Look at the range, and is 0 to 1, that's perfect. And then we can start to add points. So for example, let's say we want everything up to 0.8 here, meaning until the animation gets like this, to stay at 0. So we can take this point and we can decide that at 0.8 we want to have 0. So now this slider is just gonna push the planet after we reach that value that is set on X. The X value is this slider value, and the Y value here is basically the value that we want to output here. So now we can just play with this, and if we want a bouncing animation, we can just add some points like this, and when we play with the slider, not the hologram radius, sorry, the reveal effect slider, you kind of get this between 0.8 and 1, we get this bouncing animation. And I'm going to show you in the final result what values I used, but you can play with this any way you want to get the effect that you are looking for. So let's get to that part, showing you the finished product. Okay, so this is the finished file, and in the H section of the parameters we have a rotation of the planet. I'm going to show you how I did that. We also have this motivation on off, that is the reveal effect that we worked on the last. We have this motivated intensity that controls the number of particles, their speed, the pattern distribution, and the particle size and size seed, because we have a variation. All of these parameters, we have it here. So let's look first how we started. We have the hologram radius that we used for these values, and for the intensity, this animated property here, we just multiplied it by a big number and pass it to these distribute points like you saw in the video earlier. This is the reveal effect input, 0 to 1 scale. We use the bounding box and the z value to build this mask not equal to the z position. And for the speed control, we expose the seed and the speed for this random value node. I ended up using maximum possible speed, and that was of not maximum, 0.25, but you can increase it to make it move faster. And of course, you can animate the value to make the particle slow down or speed up. And that's the idea. You have a lot of control. For the size, I just went in this model, the instance points, and added a random variation. And because I wanted to have only one control for the size, I said, okay, we have a slider from 0 to 1 that controls the size. And then by dividing that value by 10, we make sure that we have a variation in size, with the smallest particles being 10 times smaller than the biggest particles. So now we have one slider for the size here, but this can be also pushed above 1. I made it to have a higher range, like 5, and you can make the particles a lot bigger. Or you can press backspace and reset it to a 0. Okay, so this is for the particles. Now I'm going to show you this correlation between the hologram and the reveal effect. I use this color ramp like I showed you, and with these values, I'm just going to click to this node. Starting from 0.7, we have this size of the planet, and then at 0.8 we have this size, then 0.83 this, 0.87 of this motivation FX slider, we have this value, and so on and so forth. For 91, for 94, for 97, and at the end, of course, we have one with 1. And for the rotation, and this is the cool part, I'm gonna show you how I correlated this rotation with the shader in the next video. What I did was using this transform to control the rotation on the z-axis. As you can see, this combined vector has nothing on the x and y, just on the z. Scene time, a multiplier, that is our speed here, and another multiplier to keep this value smaller, because I wanted to have a rotation speed between 0 and 1. If we look at this exposed parameter here, we have a 0 to 1 slider of range, and we have a bunch of values possible, but rotation was just too big, so I divided by 10 basically by multiplying by 0.1. So this is how I made the planet rotate. Thank you very much for staying until the end. Hope you learn a lot from this part as well. Don't hesitate to put your questions in the comment section. I will try to answer them to the best of my abilities. And if you enjoyed this tutorial series, stay tuned for the final part where we will be looking at the material. That's going to be really, really cool to see just how this shader was built, the one here, including the procedural continents, and how all this information that was passed from the geometry nodes about contact points and the tracer animation was used in the shader. So I think you'll find this interesting. I hope you'll find it interesting, so you can stay and watch that part as well. But until then, thank you again for supporting this channel by subscribing, liking the videos, commenting, and last but not least, purchasing the project files. Thank you very much for your support. And until the next video, have a nice day and happy blending.